professor, and doctor. Dr. Lee Smolin is a theoretical physicist who has done most of his work on quantum gravity. He's co-founded a number of approaches, including loop quantum gravity and relative locality. He has broad interests and has contributed new ideas to cosmology and the foundations of quantum mechanics. Dr. Smolin is a founding member of the Primitive Institute for Theoretical Physics, an independent residence-based research institute devoted to foundational issues in theoretical physics at the highest levels of international excellence. He was formerly a professor at Yale, Syracuse, and Penn State universities, and had held postdoctoral positions at the Institute for Advanced Study, Princeton, the Institute for Theoretical Studies, Santa Barbara, and the Enrico Fermi Institute, the University of Chicago. He has been a visiting professor at Imperial College London and has held various visiting positions at Oxford and Cambridge universities and the universities of Rome and Trento and Sisa in Italy. He is the recipient of the 2016 Prose Award in the Cosmology and Astronomy category, given by the Association of American Publishers, the Queen Elizabeth II Diamond Jubilee Medal, awarded in 2013, and the Major Anna Prize, awarded in 2007. Dr. Smolin was named one of the 100 World Thinkers by Prospect Magazine in 2015. He is the author of 5 semi-popular books that explore the physical ramifications of the big open questions in physics, plus co-authoring a book with Robert Unger. These include Einstein's Unfinished Revolution, The Search for What Lies Behind the Quantum, and Time Reborn, From the Crisis in Physics to the Future of the Universe. Born in New York City, Dr. Smolin is a high school dropout, a graduate of Hampshire College, earned his PhD at Harvard University, and enjoys messing around in boats. Dr. Smolin's talk is A World in Time, a universe made up of views of its past. By the way, this may or may not relate to music, because we musicians, of course, know that music exists in the ether of time. Physicists used to think the universe contained ether. Now we don't. But nonetheless, music might just exist within that ether. I turn it over now to Dr. Lee Smolin, and will just remind all of the participants here with us that we will take questions at the end of Mr. Smolin's presentation. Dr. Smolin, it's yours.
Thank you very, very much. That's a very generous and a little bit frightening introduction. I hope nobody is scared away. What I want to do today is talk about time, which is the main thing that I'm interested in. After a lot, basically, my work, like many, many other theoretical physicists, has been to locate places where we don't understand nature, to better understand nature, but even more strongly, to revolutionize our understanding of nature. Because as I would explain if I had more time, but I'll ask you just to take as given, our present understanding of the laws of nature is contradictory and insufficient. And we are still involved in the project that Galileo and Kepler and Newton began, and among many other people, Einstein and Niels Bohr and Dick Feynman and so many others have attempted to uncover what are the basic principles and what are the basic laws of nature. And we haven't completely succeeded, which is why this talk. Now, I am very relaxed with an audience. I have a presentation to share. Let me do that now. But I'm most interested in having a dialogue. So I'm happy to be interrupted for short questions during the talk. And certainly I hope we have a good conversation after the talk. Now, I'm going to take it I hope this, are you seeing my screen? I am, whoops. Are you all?
We can, yes, we can.
Okay. So I'm going to talk very simply and very directly about not just what time is, but why it matters. And I want to start by crediting the early Greek philosophers and astronomers for beginning, and many other people, very, very early, for beginning to think about time. Time is a mystery. Anaximander, who was maybe one of the first scientists, said all things originate from one another and vanish into one another according to necessity in conformity with the order of time. What does he mean by order of time? And is there an order of time? And is there anything that enforces conformity with it? Well, science began with a thought like that. And let's see, please change. Oh no. Wait. There we go. And proceeds to the end of time. Now, one of the really weird things about contemporary science is that after millennia of studying time, many of my best friends and colleagues have come to the conclusion that time does not exist, that there is no time, that time is an illusion, that all that exists is the world, the whole history of the world at one time, and we're experiencing maybe different moments in it, exists present together. And Albert Einstein said, and this was in sympathy to the widow of one of his best friends who had just died, and he thought this was consolation. Albert said, people like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion. Well, do you believe that? Let's see. Let's talk about the future if we're going to talk about time. Here's a statement. I want to jump right into one of the most important issues of the day, which is climate change. And you may hear somebody claim that in 2080, the average temperature on Earth will be 6 degrees warmer than it is now. Now, I want to focus on the kind of world, not the climate change issue, but what makes us think that it's meaningful to say what the conditions will be of almost 60 years from now. Well, is time real or is it an illusion? And you'll see that this affects how we think about the climate in the future. Now, when I make a statement like that, what I want to ask is, and we can have a discussion about whether the probabilities of that will come to be, but is that true now or false now? That is, it's a statement about a time almost 60 years in the future. Many of you will see it. I may or may not see it. Is it a truth now what the temperature is in 60 years? Anybody want to hazard an opinion? Does it mean anything to say it's true now? Or I can ask, what was the temperature 2 million years ago on the surface of the Earth? Is that something that is true or false now? Do you see what I'm getting at? Or is it perhaps something that is neither true nor false because the future does not exist? Maybe the future will exist when we get to it, but can't exist yet. And I can think of a reason. Maybe we have some capacity to change the future or to influence the future. And if that's true, then maybe it's just not yet determined what the temperature will be 60 odd years into the future. And I think it matters quite a lot to me as a human being, as an agent in the world, as a citizen, as a parent, as a friend, whether we have the capacity to change the future or whether it's already determined, it's already a fact. Do you see what I'm getting at? If we can choose to influence the future, then it can't be that the facts of the future already exist. Because I could decide to influence it or not. Well, this is what I mean when I say, is time real? If time is not real, if the future already exists, then in a certain sense, talking about 60 years in the future is like talking about Tokyo. It's another thing where there are facts in the matter. I have no doubt that there are people in Tokyo now and they're going about their various activities and occupations. And there are facts about what's happening in Tokyo now, or on the moon, or on Mars, or these are other places now. But in the same sense, is the world of 60 years or 6 billion years in the future, do those exist? If they exist, then time is an illusion. Because just like you might happen to now be in Tokyo rather than here in Arizona or in Toronto, where I am, it's just a contingent matter where you are in space and in time. And this is what many friends of mine argue. Do you see the point? If it's already determined what will happen in the future, going on into the future, then time is in a certain sense an illusion. Because, and here's one way to state that very cleanly. Many of my colleague physicists believe that the laws of nature are determinate. That means that they believe that the laws of nature have the capacity, if you plug into them, there's something like a computer program, and if you plug into them what the conditions are exactly now, they go crunch, 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 and predict what will happen in 60 years or 6,000 or 6 billion years. It's not free, it's not subject to our changing it or having any power over it. It just is. And therefore, any sense we have of being in time, of remembering the past but not the future, or altering the future and not the past, these are illusions. That's what's at stake. So when we talk about truth, many of us, for many different reasons, science, but also many of us are people of faith, or many of us believe in certain principles, and we'd like them. We often say it's timeless. The right of the people to life, liberty, and the pursuit of happiness is not a right in one time and not another time. It's timeless. Is truth timeless? Is there anything which is true timelessly? Or is all truth, is everything that's true now, true in this moment, but nothing that's true is about the future, it's just about the conditions at the moment. Science doesn't decide these questions, at least so far, because different of us scientists on different sides of these questions take different points of view, and there doesn't seem to be anything. Of course, some people think differently, but my view is that there's nothing that forces us to choose between these views. Now, many people, if you follow the quantum gravity literature, which maybe you don't all, But it's a little bit, that's where it comes from, black holes and expanding universes and many universes and all that stuff. You hear a lot of talk about time emerging from timelessness. And we could come back later and talk about what they mean by that. But there's another possibility, and I worked on this with Roberto Manguibera-Unger. Does law emerge and evolve in time? That is, are the laws of nature permanent? Are they unchanging? Or do they evolve? Do they change in time? What is the nature of change? Can change change? As my friend Roberto would say. And this brings us back to the question of, is the future already determined, or is it open? If it's open, maybe novelty is possible. By novelty, I mean genuinely new things in the world that didn't exist before. Those musical compositions we listen to didn't exist before they were composed. I will insist that the composers created something that was new each time they made a piece, composed a piece. And that's very strange and interesting if you think about what it means that I, as a human being, can make things in nature which have never existed before. A related question, if we knew everything about an instant of time, would the laws of physics tell us what happened next? Or could we be surprised by what happens next? Are there different kinds of laws that apply to the universe as a whole, as opposed to parts of it? And here I'm coming to the end of my questions. Do we have more or less freedom as we grow older? That's something I'm sure many of you haven't thought about yet, but it's something that I've started to think about. And I think you may, I hope you will get to the point where you think about it too. And then finally, what the question I was circling around, which is, what is the wise response to future risks, such as climate change? If I give you that we don't know what's going to happen, just like we don't know what's going to happen every time we get in a car or a plane and go somewhere and expose us to some risk, what is the wise response to that? And I'm going to skip to this, and then I'm going to go to some answers to the questions I've been raising. So Tom Shepard is a contemporary playwright in London. I think he's very good. I don't know if you know his plays, but he has a play in which there's a character called Thomasina. Thomasina is a kind of genius, and she lives in the 18th century in the play, and she has a tutor who is trying to encourage her in her precociousness. And here is a thing that she says to her tutor one morning. If you could stop every atom in its position and direction, and if your mind could comprehend all the actions thus suspended, then if you were really, 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 really good at algebra, you could write the formula for all the future. And although nobody can ever be so clever as to do that, the formula must exist just as if it could. And that's the argument for the world that's determined where time is an illusion. Because if there exists that formula for all the future, we have, whatever we think, we have no actual ability to change the future, to influence the future. And here's, I just want to introduce some language. When we think that our experiences in time are illusions, and what is really real is outside of time. That is, when we think that behind the world of change, there's some deep beauty and deep truth which live outside of time, we are thinking about the world from a perspective out of time, as if we were somehow ourselves out of the ever-changing universe. One way we get into that habit is by thinking about the world as mathematics. And I'll come back and talk about that. So I want to introduce the opposite perspective, and I will, well, this is an experiment. This is work, what I'm about to say is work in progress with Clelia Verde. It's risky even by the standards of theoretical physics or the kind of work I do. But I'm going to argue that quantum physics is in time. And what I mean by that, you'll see, is that time is real, but only because of quantum mechanics. And I'm going to just give you a soliloquy, a poem, if you like, to a picture of how the world may be if time is locked into quantum mechanics. Now, some of you may, now this is why I hate just not being able to see an audience. I'm imagining that most of you all don't know what quantum mechanics is. Am I right? But so what I'll tell you is only that quantum physics was a approach to physics which was invented starting about a century ago, and which seems to govern how atoms and radiation and elementary particles and nuclei and all the smallest, most fundamental things described. And quantum mechanics is not deterministic. Quantum mechanics does not let Thomasina's equation exist, because according to quantum mechanics, the future is indefinite and uncertain, which says that the better you measure where a particle is or where an atom is, the worse you know its trajectory or its speed or its momentum or however you want to say it. So between those two things, it's impossible to predict the future very well or perfectly. And that's called Heisenberg's uncertainty principle. So let's go on into that a little bit. Lots of people say lots of nonsense about a wave function describing many universes. And that's certainly, we're not going to talk about that here. If somebody wants to talk about it, we can go outside later. But what I will talk about is a universe which is single. There is one universe, I will claim, which is one reason why things matter, because there's only one copy, one life, one version of us. And that universe can be seen from many different viewpoints. And that's the kind of picture of the world that I want to develop. So quantum mechanics asserts that there are many things about nature that are indefinite, that we don't know and can't know. When will a radioactive nuclei decay? We only have a half-life. When it does, which direction will the neutrino go? The neutrino is one of the particles produced in radioactive decay. And which direction will it come away from the nuclei that's decayed? When we look, where will we find the electron in the hydrogen atom? Will the spin of that electron be up or down? So these are many things that nature, that quantum mechanics asserts are indefinite. We can speak of them, but not with any certainty. While other questions are definite. What time did the nuclei that decayed yesterday decay? When it did, which direction did the neutrino go? When we looked, where did we find the electron in the hydrogen atom? Was the spin we measured last Tuesday of the electron pointing up or pointing down? And notice that these are all questions about the past. And I think, whoops, these, which were indefinite, are all questions about the future. So I would like to introduce the idea, here I'm saying it, that in quantum mechanics, when we talk about the indefiniteness of the world, when we talk about the uncertainty principle, wave functions, probability, we're always talking about the future. And quantum mechanics asserts we can't know everything about the future. So our description of the future is as indefinite. But we can know about the past with definiteness. And there's no problem with the uncertainty principle once the experiment is complete and in the past. The particle may have had some trajectory and then it was somewhere and then some trajectory and then it was somewhere. And we're allowed to talk about that in quantum mechanics as long as we're talking about the past. So these questions I raised about the nature of time, the nature of the future, can we know things about the future? Is the future determinate? Are addressed by quantum physics. And this is fascinating to me. The uncertainty principle, I think I did define it, but I'll repeat it, is the principle that says that you can't predict the future of an atomic system because if you know where it is, you don't know where it's going, or vice versa. And Werner Heisenberg, who invented the uncertainty principle in about 1925, 26, had this to say when he started to think about time. This formulation makes it clear that the uncertainty relation does not refer to the past. Now, Ernest Schrödinger was another of the discoverers or inventors of quantum mechanics, and he was a little bit more mystical, but he said this: for eternally and always there is only now, one and the same now. The present is the only thing that has no end. And I'm going to skip Freeman Dyson, who is was a great physicist and a great friend who died recently. And I'll end by saying that our vision, those of us who are working in this idea, is we're not going to begin thinking about the world in terms of the future and the past. The world is based on one distinction, that between things that we know definitely and things that we know indefinitely. And I'll stop there. Thank you. Are you all there?
We are indeed.
Okay, great. So I thought I'd stop there and I can go on a little bit, but I think I've given you lots to talk about.
Boy, that does. I'm going to ask those in our audience. You may need to take a minute to think about all this. This is not easy stuff, Dr. Smolin, as I'm sure you well know. But you end with something rather intriguing, which is you move away from the notion of time, I think, to questions about, or rather to categories of definite and indefinite that are more than time and more than material or more than atoms or more than anything. Can you elucidate that just a little bit more for us?
Sure. I just didn't want to run over you all like a steamroller. Where this is going, by the way, let me put this in context. You all remember that we had a pandemic a few years ago. Come on, that's supposed to be funny. And in the pandemic, many of us were locked in. That is, here in Toronto, in Canada, we could take a short walk, but we could not go far from the house for a number of months. And my friend Claudia Verde was in a similar situation in Milano. So, like a lot of people I know, we talked a lot. We had an interest common in science and in poetry. And we talked a lot over that hard period that we were all confined. And this is what we started to talk about, which is the future. And whether the future is determined or not, whether we can address it, whether we can change it. And since we happen to be both very interested in fundamental physics, it became a question about fundamental physics. And where it really became interesting is when we talked about quantum mechanics. And where I'm going with this, where we're going with this discussion, is a picture of the world called Presentism. Now, I have a friend who used to say that she was a presentist because she liked to get presents. And that's, again, I'm trying to make jokes here. But a presentist is somebody who believes that only the present exists. And if you believe that, and I am increasingly come to believe that, then you have to grapple with the fact that the present is always different. It's always changing. And the present seems to be made up of moments. You have a momentary experience of the world around you, and then it's replaced by another one, and another one, and another one. And how do these glimpses into the present and the past, because when I look around, light, because it has a finite speed, brings me images of the past. So how do I integrate these into our picture of nature? These moments which keep coming from the past. And I want to call them views. That is, a view is what comes from the past to any event, to any atom or person or what have you at a moment. And I think a lot of us think that the world is very complicated and there's a past, and last year is still around and the year before that, and it's all very solid, and it's in some metaphorical sense what holds us up. And the image that we're developing is that there's nothing out there that comes from the past that still is there. The past was there, it's gone. The future is yet to come. And we are just in the moment, which is a continual recreation of the world every moment. That's kind of where we're going.
Okay, let me ask about that because you're speaking about, and we'll have questions that they're coming along, but
Okay.
the way you're defining presentism, is it on a scientific, theoretical, and cosmological level? And how does it relate to human consciousness? Because clearly we as humans have memories, which is also to say that you can't have music unless you have memories. Because any moment that you hear in music has to somehow be forged in the crucible of what you heard before and what you might anticipate to come. Or else there's no sense of a musical composition.
Yes.
So I'm a little confused, and I suspect some of our listeners are as well.
Oh, I'm deeply confused by these questions. Deeply, deeply. But here it is. Well, first I'll take the what is it? The bomb that's about to explode, the hand grenade, and talk about consciousness. And then I'll throw it back to somebody, and I hope it doesn't explode when I'm discussing it. Consciousness is the hardest problem in science, in my opinion. In my opinion, it is a problem in science. That is the fact that we are conscious, have experience, is a fact about the world, and I'm what a philosopher would call a realist about that. Some philosophers, like, for example, my friend Dan Dennett, think that consciousness is an illusion. And I don't get it. We argue often. Well, I haven't seen him in a few years because of the pandemic, but we have a habit of arguing always about that. And I don't get it. It seems to me that it's undeniable that consciousness is real, that my experience of colors, of thoughts is real. And therefore, since I'm a naturalist, it must be part of nature. But how it's part of nature is to me a very, very hard problem. And I'm only starting to admit to myself that I'm thinking about it a little bit. So, yes, I think it fits in. I think consciousness is an aspect of the present moment. If that's not vague enough, give me a chance and I'll be vaguer. I think the present moment is what the philosophers call thick. That is, if every experience in time were infinitely or infinitesimally short, and we just heard these short little glimpses, we couldn't understand anything. That would, not only could there not be music, we couldn't get up and walk across a room. So somehow the present has embedded on it a longer interval. And that's something that some neuroscientists have been studying. For example, if they give you, if they put you in front of a display and give you a button to push, and you're supposed to push every time you see a light go on the screen, a blue light or a red light. And then they get a little bit more sophisticated and the lights get very close together, splash, flash. And they ask you to hit the button with the green light came before the red light. And that works down to about, I forget the figure, but maybe a 10th of a second. And then it doesn't work. Then we perceive the flash as having an ordering time, but we're often wrong about the perception. So there's a lot of interesting science here, and some of it is very pragmatic because it would be often nice to know how the brain works. But some of it is really at the edge of what I think we even know how to talk about.
We have a question here. Let me ask. Can the future be undetermined vis-a-vis quantum physics, but determined on the Newtonian scale, or the scale within which we experience life and ourselves?
That's a hypothesis that many people have. And I think that is, maybe quantum effects are restricted to very, very small scales, and they don't affect the average behavior. So that when I decide I'm going to move my hand over here and move it back, there's nothing quantum mechanical happening in that decision, which I made indeed as I was speaking about it. There are lots of people who believe that, and they believe that quantum mechanics has nothing to do with how the brain works or with consciousness, that those are all phenomena on much larger scales. I used to believe that, I was about to say religiously, but confidently. I don't anymore. And I don't know what's true. That certainly we can make quantum phenomena that are larger and larger in scale. We can take two nuclei and put them in a superposition of states, entangle them, as we say, and put them at distances of some kilometers. and they remain entangled and coupled with each other in that mysterious way. So it doesn't seem that there's a principle that says that above a certain size, physics must be classical.
Mm-hmm. So what's the benefit to gaining a quantum perspective in a practical human sense? And let me add parenthetically, maybe to that, something that may be useful. You've already mentioned Heisenberg uncertainty principle. That always seemed to me to suggest, or previously to your discussion, that there's a random nature in the world that we can't understand. To which, of course, Einstein famously said, I don't think God plays dice with the world. But your comments leave me with a much more optimistic sense of the Heisenberg uncertainty principle, which is to say that it allows for, or suggests that maybe if there's any correspondence between the quantum and human world, that humans in fact do have agency, that we can make determinations about how we wish to act, what we wish to do, how we wish to approach the future that we don't know is coming. Mm-hmm. And then in fact we can make a difference. I know this, I don't think you're suggesting that we acquiesce and simply say what will happen, but rather some of the things that we do as humans can affect other human beings and certainly will affect the nature of events of the world. And maybe I'm getting a little too far-flung and too verbose here, but it brings us to a question of history, which I know you've worked on as well. The great man theory versus social class theory. Is it a great man who or woman who does something that makes the future event happen? Right? In other words, that we humans can affect the future. So that was a bunch of things together. I apologize for being a little bit too wide in my questioning.
Well, I'm interested in all those questions. I think they're relevant. But to come back to, I think, what was the first question?
Yeah.
Why does it matter how physics resolves the question? And I think that, first of all, our society right now is very incoherent and very confused. That's the only way that's the most generous way I can describe what I've seen in our society in the last several years. And I think we're incoherent because people don't talk to each other enough, who have different views and so forth. So I'm a big believer in diversity of opinion, in diversity of approaches. At the same time, I do believe that there is truth. There are things that are right and wrong. So for me, science is a part of a democratic society that expresses certain ideals, which is that we want to know the truth. We believe there is a truth about what it is, and we want to know it. And that, to me, comes down to two principles. One of them is if the truth of some question can be established by reference to evidence that is public, that everybody can study and learn from, then we must regard the questions as settled by evidence. And that's the first pole, I think, of a democratic society. The second one is in cases where no amount of evidence will decide the problem, I think we have to be respectful of different views and different approaches to that. So to me, science is not a method, it's not a club, it's a kind of club is the wrong word. Science is something that those who share certain values have access to. If you believe that the truth is there and that we can work hard and find it eventually, then you're in the scientific society. Now, this may seem like a long way around, but if your science gives us a bleak picture of the world, then that's a problem. And many scientists do that. For example, my teacher, Steve Weinberg, very famously in a book that he wrote about cosmology, said the more we know about the universe, the more pointless it seems. Because he had a very bleak understanding of the relationship between life and the cosmos, in which the cosmos was cold and dark, and there was nothing to nurture us there, and our existence in it was somehow accidental and pointless. So one of the things that I'm thinking a lot about is the work of some friends and colleagues. For example, Marina Cortez, who try to understand whether the universe is somehow open to life, that it's a place that's very friendly for life, even if you have to ask some interesting questions to get to that. And I think it matters whether we live in a universe that's hospitable to us or not. And I think that a world in which we have agency in time, and in which, you see, the universe gets something out of it too, because if time is fundamental and real in the sense that I've described, I haven't gone into it in this talk, but then the laws have to be changeable and evolvable. And then we're all, I don't want to say the universe is alive, but it's somehow come to evolve to be in a state which is hospitable to us. And all of a sudden we can feel at home here. And I think that matters as we're going to have to more and more fight and argue to keep it hospitable, or to keep at least this kind of. Sorry, so I think I matched your excursion with mine. Maybe let's have a question from some.
Yes, but it was a lovely excursion. Um, oh boy, we have some long questions. So we're almost at 6 o'clock, and we often try and finish at around 6. I'm going to ask our participants forbearance, which is to say we'll go about five more minutes because this is too exciting, and then we will close with some music. And then, by the way, Lee and I will talk for a little bit in an informal manner for anybody who would like to hear an informal discussion or a continuation of some of these ideas. Just know that the past for Lee and me does exist because we were both very young students together at Hampshire College, and we both had much longer hair at that time. So I know that the past exists, that it's not a complete, that we're always in the presently. I just want you to know. But here's a couple of questions from people. What are your thoughts on the idea that perception is reality? In other words, time is real because we have a perception of time. The future is real because we have a perception of it. Consciousness is real because we have a perception of it. This has always been my personal philosophy, says this person, and I'm curious about it. In other words, perception.
I don't call it perception, but remember when I talked about a view of an event, which an event is not a person or a mind, it's just something that happens in the universe that changes something indefinite to something definite. That every event has a causal past. There's things that led up to that change from indefinite to definite. And that I call its view. Its view is what it, if it was capable of knowing something, it's what it would know about its past by virtue of some of the things that it saw when it looked around. Well, I'm being very imprecise there, but I see it possible to formulate a picture of the universe as all those views. And that is as a collection of all the views of itself, if that makes any sense.
Okay, I think it does. I'm going to ask you one final question because it pertains to a couple of questions that have been asked. So
Okay.
you have talked about not scientific method, but rather a scientific understanding or approach to how we know the universe and ourselves in it. You have spoken just at the end as the universe as being, in an anthropomorphic sense, perhaps a friendly place for us humans, if you will. Does this allow for an understanding from a religious basis as well? I have to ask that in close, as a number of people have posed something along those lines.
Yes. Those are very difficult questions for me because it's, for me, the two principles that I enunciated leave faith in a distinct region of knowledge from science, because scientific knowledge can be checked against public evidence. And I don't think that what people usually call religious or spiritual knowledge can be. I think when religions attempt to conflict with science, they're making what the philosophers call a category error.
Yeah.
That is, what they seek can't be found in science, and vice versa. Now, I am actually a big believer in the principle, which I think is part of not just democracy, but American democracy, that what our neighbors believe doesn't, Thomas Jefferson, or I forget the rest of that phrase. I don't like to talk about my spiritual or religious upbringing or education because I don't want to impose that on anybody. And I really don't want, I'm not involved in that project, so I don't want to pass a judgment on anybody else's. The only thing I ask is that whatever you believe, you leave room for people who are different from you and whose criteria of truth is, and you recognize that evidence is the most important criteria of truth. So that was evasive, but
No, that's evasive, but very nice as an American statement, also, by the way, because you are American, even though you're living in Toronto, I think, about how we need to approach
yeah.
each other, each other's beliefs, and different ways of understanding the world. So, Lee, with
Yeah.
that, I'm going to close the official presentation. This was just tremendous. Just so you know, I should have mentioned, we've had many presentations from political scientists, from economists, from constitutional lawyers, from jurists, from artists. You are, in fact, our first scientist or hard scientist. And I'm so grateful for your presentation. And I think I will speak for all of us and thank you. I should have asked you if you are willing to stay on for a few minutes after our final musical
Yeah.
presentation. Wonderful.
As much as you like. Maybe I'll just go and get something to drink because my throat's a little parched, and I'll be right back.
Go ahead, and we're going to have one final performance. I'm just going to express to our audience this will be a performance again by Professors Cantor and Lynn, and they're going to play a piece by Edward Grieg, and they're going to finish with Elgar, excuse me, with Edward Elgar, the second movement of one of his sonatas. And I want you to think just a little bit. What we've been talking about is the mysteries of the universe and our trying to understand it. Music is one of those ways that we try, in fact, of understanding the mystery of ourselves as being human and the mysteries of the universe. It's quite an astonishing thing, this thing, music, that we hear it, that we play it, and that it brings us great joy. So I bring you for the final, until the after party, as it were, this performance by Professors Cantor and Lin. You're on, guys. I thank you both so much. That's a lovely way to understand the universe. I hope the universe heard your touch on the piano and your vibrato and rubato, because it was time played gorgeously. Okay, thank you guys. You can join us if you would like, or go home, whatever you wish to do. Thanks so much.